Yeah, everyone see my screen here. Is my screen visible?
Yes.
Okay. So let us start with list and tuples. So the list and tuple both are linear data structures. It's like storing a list of values, a linear array of values. So both are used for storing that kind of values. So let us start by declaring a list and a tuple. Okay. So the list, for list we use, or let me call this list L1. And for we could have any number of elements like integers, and also the list could contain a mixture of different data types in it, like a hello, and we could also have a list nested inside it. We also have any other data types like tuple, instance. Could also have that. Okay. So in list, this is declaration. So we declare a list with the square brackets and in terms of content inside. And we could access the elements of the list using indexing. Right? So the first position in the list starts from index 0. So L1 of 0 will be the one here, and L1 of 2 will be the third element from the list. See, it's the index 2, not this. So it will be, the 2 will be in the index 1. So you could run this program. Yeah, you could see here, the zeroth index, the element of the zeroth index is 1, and the second index is A, is printed. So this is how you select a index and elements, pick an element from a list and print it. And another thing in the list is you could choose a subset of a list using slicing. Slicing helps us to choose a subset of the list by selecting a range of values from the list. So for instance, we shall take from this first element S2 and up to this element at index 4. So to select up to element at index 4, you have to set the limit as 1 to 5. So the last index is not counted in here. Here you shall check this. Yeah. So it's up to 1. So the first index is included, but the last index is not included here. And you could also do the indexing like this. So if I do it from the start, you can just leave out the first parameter. So it includes the list from the start. And similarly, you could choose up to the end, like leaving the last parameter. See that? So this goes up to the first one to the last one. And in indexing, in list, you could also have negative indexes, negative indices. Like, so the last element will be indexed as -1, and this is -2, and this is -3, etc. So you could also see that. So let's check on -2. It will be this element here. Yeah. See that negative indexing also works in the list. And you could also have like you specify the step in the main function. You could also specify the slice step also here. Like from I could have to take the even elements. That's the elements of the even positions like 0 and 2 and 4, etc. I could do like this. So this is from the start and till the end, and I would choose the next step as the step parameter, which is 2. So you could have 0 here, or yeah, it would also will be the same. Starting from the 0 is also starting from the beginning. So this would print this elements at the even positions. Yeah, see that is element 0th element and the second element, and the element as index 4 would be printed. You could also use a step parameter, and you could also use this one to reverse the list. Like if the step is -1, it will go all the way from last to here. See that the list is reversed here. So this is a shortcut you could use for reversing a list. Yeah. So this is how you use the start and stop and the step parameter. So it's what's like the number index. It's produced by the range function. Similarly, okay. So all these operations we did on this list is also supported for the tuples. You could print this index any elements from here, and if you want to change the elements in a list, you could also do that. Like if you want to change the element here at the position 1, you could do L1 1 is equal to any other element like 3. And if you print the list later, it will be changed. The second element at the index 1 has changed to 3, as you can see here. And there are different functions that are within the list. You could see that, like you could add an element to the list in the program. Like if you want to insert an element at the last index, add an element, have the function append. Just have to specific element. We have this element add appended to the list. We have this pop function that removes the element from the list. Like usually it removes the last element. You can see the last element have been removed from the list. And the one thing, this function call does not return a new list. So this function call does not return a new list, but it modifies the list L1. So if you use L1 equal to like this, so this does not return a new list. It just modifies the list and returns none. If you print L afterwards, it would be none. You could see here, because this function append or any other function that you call on this list only changes the list and not returns a new list. This is the most common mistake some beginners do. Like if you want to add a new, so like sort, so there is a function called sort also. So if you want to sort a list, they assign it to a new list instead like this, and they perform another function on this list. So it would produce an error because this sort function is returning none, as you can see here. So it's returning none. So it does not return a new list. If you want to have a new list produced by this, you could use the function. Like, so sort doesn't accept any arguments, it's just sort like not. You could also have this key and reverse parameter. So the key is like what on what basis you could do that. It's like a function that is called upon that value to get a value that you can sort. So that's more complex of it. Usually you could leave that parameter and it takes the values as well. So if you do this, L1 will not be a new sorted list. So that you have to remember. If you want a new sorted list like L2, you could use a sorter of L. You could use that function. This would give us a new list L2, which is sorted. Sorry. Yeah. Also, we are having a mixer list here. So if I doesn't want to compare these different data types, so you could have that. It still 3 here. Still the random list here. Small on L3. Yeah, you'll get a sorted list. If you use this function L3.sort, it doesn't produce a new list, it just produces none. So if you want to have the sorted list, some other thing, you want to have you have to use the sorted function. And you could sort a list in place and you could pass it to any other functions like L3. So it will produce, so this function returns none, but it has sorted the L3 in place. So when you are using L3 again, you will have the sorted list here. So it sorts in place. So now the L3 will be changed to the sorted list. And we have another functions like insert, which you have to specify the index to index, set a new element at a specific index. And the pop also, you could see is to remove what index you could have removed. Like if you want to pop out the element at the index 2, so say in L1, L1.pop of index 2, it will have removed that element. And the pop, as you can see, it also returns that element that you have popped. So if you want to pop some element and store it in another variable, you could do that. Like a is equal to L2.pop. Now the L2 doesn't have the element at the index, but the A will have the element that we have popped here. Yeah, you can see that A is removed from L1 and the popped element. So this function returns something, the element you have popped, and that element will be stored in A and we have printed that. So in this case here, the second element we have popped, you could specify. If you don't specify the index default, it will pop the last element from the list. See, it have popped the last element, so it's removed from the list, and VA has it. And there is a function reverse and then other sort of list functions could have. We could check on it. Any doubts in the list? Anybody? Or you want to clarify any particular topic about list and go to that? So list. Okay. Yeah. Am I audible? Anybody?
Yes, sir.
Yeah. So now we could go on to tuples. So it's similar to list, but you have there's one difference. So we'll go through that one. So first we just initialize a tuple. So a tuple also could have different data types, anything like that, and same indexing. Everything works like the indexing part works like the list. Then if you go out of index, it will produce a error. So there is only three elements. So the last index is 2. So you could have this is also same for list. You would get an index error. It's also true for list also. And So the one thing that differentiates tuples from list is you could also have a list tuple defined like this. This bracket is not necessary for that to be a tuple. Could initialize a tuple like that. See, it also works the same way. And we could check on the type of this. B tuple. Sorry, type. And you can see it's tuple. So what does this mean? If you want to have a tuple with a single element, can't have just like this. So you can see it's of class int. So it's similar to a number one, just enclosed in a bracket. So what you have to do to make this a tuple is you have to have a comma there. So comma is the one thing that defines a tuple on the brackets. You could also have something like this. See that? Yeah. So this comma is that thing that makes this a tuple. Most people confuse that. That's the bracket that makes the tuple. That's a common thing used to refer this as a tuple. But the comma is what that makes this as a tuple. Yeah. So we can use this parenthesis to get a feel that it's also a similar kind of thing to a list. And the one thing that differentiates the tuple from the list is that the contents of the tuple cannot be modified as we can do that in a list. Like if you want to, if you put an index using any other different methods like slicing, like setting, taking an element from range to range, you could all do that, but you couldn't modify that. That's what so if you want to have change the element of the index 1 from 2 to 3, it's not possible. And tuple. See that tuple object does not support assign. So it's because tuple is an immutable object and the list isn't mutable. That means immutable object means that you could not change, you cannot change the value as the runtime goes. It would have a fixed value, you could read it, but you cannot change or modify that. So that's an immutable type, and tuple is an immutable type. But list you can change as the program goes on. Change anything, you could add, you could remove, you could pop out, do anything, but that's not possible to have an element. That's all. Yeah, you could also sort. So what this will produce? Think. Anybody? Anybody could tell me what this line will print? Okay. So tuple doesn't have this function sort, so it's only defined for the list because the sort function sorts the list in place, that's modify its content in the same memory. But you couldn't modify the tuple, right? So you could, it's intuitive that you cannot have a function sort like this that modifies the content of the tuple. Right? So what you want to sort the elements of the tuple, just call the sorted function. So it creates a new tuple that's sorted. So it's also always prints a list, I think. Yeah, they have written it as a list. The sorted function return it as a list. So you cannot modify the list. a tuple, and you could convert this into a tuple like using function. It will create a new tuple for us. Yeah. So this is because the content of the tuple cannot be modified. Once defined, it's a built-in mutable sequence. And this tuple comes handy in another use case, like if you want to declare um, so this is called unpacking tuple unpacking as they call it. So you have an element variable for assigning two values. You do like that. So this Python thinks this is a tuple and this is a tuple, and it unpacks this tuple and assigns it to T1 and T2 respectively. Check on that. Yeah. Come on. Two is a useful function that's associated with tuples. Call this unpacking. Like, so this is a tuple, right? So this tuple is unpacked and it's assigned to this variables. See, T1 has the value 13 and what it have different number of values. What is an error? Too many values to unpack. So there is 3 elements here, but we only have 2 elements here. So you couldn't unpack that. We have the 3 here, we will do that. This unpacking helps, it's also used to pass a different number of arguments to functions that we come on to later. So it's an useful feature. And if you want to have T1 is 13 and the remaining any other elements that are compressed and stored in T2 would also do that, like and this, as you can see, T1 has the value 13 and the remaining elements are packed into. So this is called packing. You also pack some elements of the list and put it in the same variable that you can. So this kind of notation comes helpful when you are passing an arbitrary number of arguments to a function that we could see later. Any doubts or anything you want to discuss in tuples?
Yes, sir.
Okay. So next, I think we have something about while loop. Okay. So we shall discuss that. So while loop. So while loop is a common looping structure that was like checking a condition after every iteration to check whether you have to continue the loop or get out of the loop. So it's defined like the syntax starts with while, and here we have the condition here. Here we have the condition, and this is the function body. So our function body is the loop. The body of the loop is here. So when the while loop is initiated, so it checks this condition that we defined over here, and if the condition is true, it does the content in the body of the loop. And whenever this condition becomes false, it goes out of the loop. So we need some kind of control over here. We have to have a variable so that updates in every loop, and the loop checks that variable value to conclude whether I have to stop or I have to go on to the loop. So usually we have some kind of variable like this. If you want to have a loop going on n times, we could do like control variable I initialize to 0, check whether that I is less than n or like 10. That hello, and you run this loop. This value of the I will be always 0 as far as now. So we have to increment that I to add its value after each iteration, right? So this statement increments I after every iteration of this loop. So this is what we get. Allow to get 10 times. So it goes up until this I becomes 10. You could also print the value of I here. See, at the first iteration, the value of I is 0, and it's incremented up to 9. And after we print this value, we increment it to 10, and this condition becomes false here, and it takes it up. And the contents after this loop will be printed, and we have come out of the loop. And there are two other interesting statements that also helps us to control this loop. So they are called break and continue, right? So break statement to be used inside a loop. It cannot be used outside of a loop. So you simply have this break statement here. The loop breaks after this two statements. See that? It came directly out of the loop. This is more useful to use a break statement like this. So we usually use a break statement with a condition. So this is the normal case whether the loop breaks up. If you want to have any other condition to also immediately break out of the loop without this condition satisfied, you could have that break here. It's like another variable a. So let's have I equals 5. Just wait. See, the value I is printed as 5, and it suddenly break out of the loop. Considering this one. So this is break statement. So this break statement you could use to break out of the loop in any case. If the program encounters a break statement in the loop, just goes out of it. And the continue statement is used when you have to do like a certain part of the loop, and if some condition is satisfied, you just go from there and in the loop of the beginning. So it just continues, but not lose the remaining part of the body of the loop. Right? I have this instead of break, I use continue. So if it's equal to 5, I'll just continue. So this will give us an infinite loop. Whenever this is 5, it do not do this part. So I just add this part here. By the remaining content, I just add this. So print this. See, in every iteration, the remaining content is printed, but not this when the I equals 5. After this 4 is printed here, the value will change to 5, and this remaining content of the loop is not printed there, because this continue statement tells this loop to leave out the remaining content of the loop and just begin from the top. That's the use of this continue statement. Any doubts?
So the last part where you added.
Sorry, I couldn't hear you. Please speak louder.
Am I audible, sir?
Yeah.
So the last part where you added print the remaining content of the loop, which I don't understand. before the line, after continue, why doesn't it print the remaining content of the loop? It is
So
outside the
this,
if condition.
yeah, so it's outside the if condition, right? So that's the part of this continue state. Whenever the continue is encountered, the remaining part of the loop doesn't execute. So it just goes to the beginning of the next iteration. So whatever you have after this continue, whenever the continue is encountered, the loop stops at that iteration and goes to the next iteration without doing the remaining part of the loop. That's the, so if you have break here, loop exits, the iteration exits, and the loop also exits, and it goes out of the loop. And if you have continue, the loop doesn't exit, but the current iteration is exited there. So the current iteration where you have do all the things within the loop, if the continue is encountered, the part below that will not be executed for one iteration, and it just begins the next iteration. It goes here. Whenever continue is encountered, it goes here and does this everything. But whenever a break is encountered, it doesn't go to the while, but it goes out of the. We have break here, just goes out of the loop. So it breaks the iteration, every iteration, it goes out of the loop. And see that, just see that whenever it comes to 5, it goes out of the loop. But when continue used, it just keeps the remaining part for that particular iteration, and it goes on. The while loop continues. For that particular iteration, the remaining parts is not executed. You see, with the fourth iteration, and if the 4 is printed here, and this value is changed to 5, and this goes on, and after using continue statement, the continue statement is encountered, so it goes here. So this remaining part of the loop is not executed whenever the continue statement is encountered. It goes to the loop and begins the next iteration.
So this is same for loop too.
Yeah, this could also work for loop.
I got it, sir.
5, 10, that. Yeah. Sorry. Oh, yeah. See, yeah, when I is 5, spread as 5, and remaining content is not executed.
So one more question, sir. So
Yeah.
if there is another condition in this if loop, let's say elif or else,
Yeah.
and if I don't put the continue properly, I mean, in the first condition itself, if I put the continue, that iteration won't check the next elif and else condition, right?
Yeah. Go to have this. So if let's have this else before. See, else is also not run. Whenever the continue is executed, if friends, it's a basic that else won't run, right?
Okay.
If a condition goes here, then the else parts are not checked. It's also it's a thing, right?
So we should be very careful while putting the continue, because if there is
Yeah.
an important condition in the next part, I cannot. It will get skipped,
So it's
right?
not true. It's not with this continue part. You could see that. Uh, so
Yeah.
if I is 5, this hello is printed, and this else part doesn't run in the else part also. That's
Okay.
also
Okay.
same without right. So
Oh,
if it's
yeah.
true, the else won't run.
All right. All right.
So it's not with the continue. Continue, you have to careful with this content, the thing out of this condition, the thing below this condition. So that parts doesn't run in that particular case.
Got
Everything
it, sir.
clear?
Thank you.
Yeah.
Yes, sir.
Thing. So this is we have those. So this is one use case of while loop where we have this certain number of things, but there is other use case that's mostly used when while loop is used. Like we doesn't know the number of iterations to do. So let's just check on some other conditions and some value is equal to some value, just exit out of the loop. That kind of cases is where while loop is used mostly, where we don't know the number of iterations. Like if we want to have to print arbitrary number of, get arbitrary number of inputs from the user and stop till the user inputs exit, do that, use while there. Like I is equal to, so it will get an input. You could check on that, like while I not equal to exit, like this asks for an input. So yeah, we have to change this. No. So we have to update the value of 5 here. It's or any other input until we can exit. So it doesn't know how many times we have to get in from the user. It's until he enters exit. So in that cases, you could use while loop. And for the iteration, number of iterations is known, you could use a for loop instead. But while loop in special cases like this, when you doesn't know the number of iteration you have to do, you could use while loop. And to create an infinite loop, just use while true, because this condition always evaluates to true, and this happens indefinitely. Also do that. But somebody also uses like this while loops, but they have a break statement if some condition is while equal to exit, break out of the loop. Also use this kind of loops. See, now we only have one input statement, right? So this we also a nice way to implement this. Yes. Okay. Any doubts in while loop?
So
Yeah.
what does this mean? While true, what is the
Yeah.
actual meaning of that?
So while always checks this condition that you have here to decide whether to run this body of the loop or go out of the loop. So when you say while true, this condition here always evaluates to true. So that means this loop will run indefinitely if you don't have a break statement here. It will run indefinitely. So it's like in C, you have this do while loop. That's right. You don't have to, you don't want to check the condition in the beginning. You just write while true. So this could be like an analogous form of the do while loop that you use in C language. So when in while, we always check the condition in the beginning. So if you have true here, this always runs. But at the end of the loop, you could have a break statement like this, where it checks the condition. So it would be a use case like do while loop and see. It could be used like that. So this loop always runs, but you could check this at the end of the loop. So you need not have an input like previously have outside of the loop here, because previously we checked at the beginning, and for checking this, we need to have an input before the loop. But in the later case, we need not have an input before the loop, because we just running this loop and checking, exiting, checking this part in the end. So that's checking in beginning and checking in end. This a workaround to do a similar thing like do while loop. Got it?
Yes, sir.
So if you have false here, what do you think will happen? The loop doesn't run. Just out of it. Okay.
Okay, sir.
So next I will go with functions. Okay. So functions. So the general syntax for this function is like f. So you define the function here and the function name. So it's here a function add two numbers a and b. So this part here is the function name, and these are the arguments to the function. So these are the function arguments. This is the first argument and the second argument. And we print a plus b here. So we have defined the function. Then we have to call that function. So like a is equal to 1, b is equal to 2. Or we could use a syntax like the tuple unpacking syntax like we did previously. Nice. Okay. Oh, okay. And you get like 3. So this function prints the sum of these two numbers. That's all. So whatever you do in this function block, when you call this, it's executed. Just have an open statement. And now we could do another form of this function. Like if you want to return the value. So this is a return statement here. Press P. Now this. So this takes in the value A and B and returns the value A plus B. Which means if you think of it kind of like an expression, this expression provides the value A plus B, and we could print that here. So this add of A and B returns the value A plus B, and it's printed here. So what if a function doesn't have a return statement in it? It will also work. So some function cannot return anything. Like the previous thing we did, it doesn't return anything, just prints these values. And if you also print this out of this function, you will get a none. So whenever a function doesn't return anything, it's similar to it returning none. So none is a object defined in this Python, which we could use to specify something null values, which will be useful in many cases. So it's similar whenever you don't have a return statement in a function, it's similar that we have a return statement like return none. So that's why a none is printed here. Whenever this function is called, this code gets executed. And we could also have different names here, like C and D. You could pass in that values C and D here. So when you pass C and D here, when you call that function, the C is passed as A within this function code. So the C will be called as A within this function, and this B will be called B within this function, and this expression, this code is evaluated, and if you return that, the values are returned. C please. So whenever you pass different variables here, that variables, the name of the variables are changed as you have defined here, so that this code runs. Within that block, the names are used as A and B. And if you don't have a D here, but this function requires 2 arguments, you will get an error. See that it is a required question argument P. So this P is required. Okay. So this adds some of this. Okay. And another thing, we could have a keyword argument, an argument that has some default values. If you don't put the value, pass the value there, you will have just like A and B equals 0. If you don't pass B, and the B will be considered as 0 by default. So this is assigning default values for our arguments. So whenever you don't pass B, it will be considered 0, and the A plus 0 will be done. So if you have 10 here, see the default, by default, the value of B is considered 10. But you could override that using by passing this value. So now when you pass D, it will be considered, when you pass B, it will be considered that value. If you don't pass that, it will be considered as 10. And you cannot have this positional arguments after this, like this. When you have a default argument, you could have a function definition like that. See, the non-default argument doesn't follow the default argument. So that's a problem. So always the default arguments are placed as the last arguments. You could also have multiple default arguments. You have, so okay, let's try to have a function 3 plus. So B equals 0, C equals 0. This will work by considering. So we have passed B, so it considers the value of B as 2, and we haven't passed C, so it considers the value of C as 0. If you pass the value for C like 10, so you can expect to be reached as this. This is called default arguments. So if that argument, that particular argument is not passed, what to use by default? And then we could have something like this. So what if you have to add some, so it's going on like A, B, C, like 10 numbers. We could have that as a list, right? Or lists. Or just, or else you could do range 10 that converted to list. And we could use a for loop, right? I return sum. Let's pause this. You also do that. So this returns the sum of the list here. That's one kind of way that you could do that. And another kind of way, if you want to have arbitrary number of arguments, as we discussed earlier with tuples, tuples, we could have something like this, like A. And now we need not have this arguments as a list. Instead, we could just pass this argument like different arguments here. As you can see, it has printed the value 21. That's because these values, these individual values are packed into A as that tuple. See, these individual arguments are packed into this A as tuple, and we just ran an iteration on that tuple and print the sum. So in this way, a function could accept an arbitrary number of arguments, any number of arguments. We could also have another argument like we just this function. So I'll just print this. Prints this and also returns this. Also print that. So you could have an argument like this. So it's defaulted to true. You could have one condition here. Only when verbose is equal to true, we print this kind of details. So its default will be true. You could also change that, like false. So this thing will be assumed for this last. Yeah. Sorry. So this now you have position like this. You can have that. So these are called as keyword arguments. Right? When you have this packing kind of things, all the arguments go there. So you have to mention this different arguments like this. So this will be a keyword argument. Pass through there. It will be printed. So when you don't specify something there, it will be. And we also have other arguments like we used B here. So the first element will be assigned to B and the other elements are assigned to A. Check that. So we are doing nothing with this B. So in this case, this A will be passed on to B and these other elements will be passed on to A. And that sum is printed. See, the sum will be 20. So that's similar to something that we seen on that tuples. Star B is equal to a list of elements, and the first one will be assigned to A, and the remaining will be assigned to B. And you could also have other variables C. In this case, the first will be assigned to A, and the second will be assigned to C, and the remaining will be assigned to E. The similar thing happens here when you use pass the arguments here. So the first element will be B, and you have a C here. The second element will be C, and the remaining will be passed on to A as a tuple. As that happens, this assignment statement also. See the values are passed there, also print A and B. It's here B and C. See that the first two values are passed to this B and C. The remaining values got passed to A. And here we have a keyword argument, which you have to specify this name of this argument in order to pass that value for. So this keyword arguments come at the later part. It will be in last. You can also have many keyword arguments like this. Yeah. Any doubts in this? So this is the function definition, and you call that function here. So why functions are nice is that you could define some functionality and use that functionality without running this. So this function you have right, it's like sum function, right? So it sums up every values you pass there. So it's just simple. And whenever you want to add certain numbers, we'll just do like this. So like lists, you have to do the same summing. You don't have to write this part 2 times. You have just call this sum here. Right? You don't have to write this loop 2 times to some 2 different lists. Just like that. So just make it like this. We process a list. Okay. We just have to print the sum of A and sum of B. Yeah, could also do something like adding the both sums. So the code will be simple, right? So you don't have to define a sum for A, sum A, and sum for B, sum B, and add that. You could use function calls like this, and using the values that we've written, you could do something like this. And you could can also call other functions in another function. Like, so you have to have a function that computes the difference of sums of 2 lists. So like another function, difference of sum of a list A and B. This returns sum of A minus sum of B. That you could call this function that's the difference of sums of this 2 lists. And you could notice something like whenever we pass A and B gives a negative number, pass B and A gives a positive number. So what if you always want to have a positive number? So we could do that, like if A is bigger, we return A minus B, and A is smaller, we return B minus C. So that's something like hello. Is anyone speaking? Yeah, okay. So we could have that function. So given 2 numbers, just finds absolute difference, as we call the difference is negative, just returns the positive. To define that absolute so this function accepts a number like positive a number that may be positive or negative. If it's positive, like if a is greater than 0, greater than or equal to 0, just return a, and if it's just else,
Next on the Python.
return minus e. So this is like saying whenever my a is positive, just return that. If it's negative, just return the negative of that. So the negative of the negative number will be positive. So my number will be always positive if it's also negative. So if you want to have an absolute difference of sums, call that absolute function. Here, and you could reuse this kind of functionality anywhere you want in the program by just calling this name of this function. So that's where functions are used. You could do anything, you could call absolute anywhere for any multiple tasks. So we define the same functionality and we use that functionalities in multiple places in our program. That makes our program simple. So, and giving this function names as much descriptive is a best practice that we follow. If you don't give a function name, just call this function B, then that doesn't make any sense. What about what this function does? If you have a nice name given to this absolute, so this function makes the absolute, computes the absolute value of the number. So that will be more easy, and it's much appreciated to do this, use function names like this. Any doubts?
No, sir.
And yeah, in another interesting thing that we have in functions is that a function could call itself. That means inside its definition. So that kind of function we call as a recursive functions. So if a function calls itself inside it, it's called as a recursive function. So I'll just give an example of a recursive function, and we won't go too much detail about that. Like if you want to compute the sum, as we have here, we have a function. We could have a function recursive sum. Of the parcel list A. I'm just writing it and I'll explain it. Just test this out first. Yeah, so there is a here. Now it works as it works like for the sum. So I'll explain how this works. It's like, so you pass a list here as A, and it takes the first value and computes the sum of the remaining values and add it to the A. So whenever this function is called, first this A, the A we have here, so we are passing B here. So the B we have here is passed as A into this function, and it checks whether the length of this list is 0. Otherwise, so if the length is 0, it just returns 0. And the sum of elements in an empty list is always 0, right? This makes sense. If the list is empty, the sum of elements in a empty list should be 0. So there are no elements and sum of this is 0. So this we call a base case in a recursive function. Whenever this function, the same function is called within the function, before returning, this calls a of 1, that's the remaining elements of the list, and pass it here as a, and does the same thing. And this goes on like loops and loops. It calls that function, and until we have the remaining list as an empty list, that's 0, and that return value is passed to the previous expression of the function call, and that's returned to the previous function call, and that's returned to the previous function call, and it goes on like that. I could give you a like visualization of how that happens. So we first pass, so let's call it sum here. Sum, when you call sum with 1, 4, just we have this for an example. When this is called, so it checks len of s is equal to 0. So it's not, and we have this remaining part return s of 0. So the s of 0 will be 1 plus s, that is the recursive sum function, and we call this with s. So I just, so this list is called a, right? I call this a of 0. A, and s is the function. Image.
Sir, we are not able to see your screen.
Oh, sorry. Just share it. Could you see my screen now? Is it
Yes,
visible?
Yes, sir.
yeah.
Yeah, okay. So I'm calling that recursive sum function. This is the recursive sum function. I named it as S here, and we are passing the list A here, 1, 2, 3, 4, and this checks like whether now A is 0, 0 or not. For now, it's not 0, and it goes to the next part. So it's within the if, right? When is equal to return 0, return 0, else, so it will go to this part where a of 0 plus will do the sum of a of 1 and the remaining. So this part will be 1, as we have here a of 0, and this a of 1 and the remaining is 2, 3, 4. And another function call of this same function, when it is called, this goes on and creates a new function call with s and a equal to 2, 3, and 4. And it goes like that. And now when this is called, it checks then of a is equal to 0, and it's not 0 yet. So we return a of 0. Here a is 2. So we have to return 2 plus the same function, that recursive sum function called on a of 1 and the remaining. And this part here is 3 and 4. Right. So this makes a new function call with s and a equal to 3 and 4. Still not 0, the length is not 0, so we get like 3, that is a of 0 here, plus s of a of, the remaining will be just 4. So not a of 4, a of 1, the remaining. It's just a list of 4. This function call makes a new function call is with a is equal to just 4, and its the length is not at 0, so it returns We have 0, that's 4 plus s of, now the remaining list will be an empty list. We just was an empty list here. This goes and calls new function call. So here s of a equal to empty list will return 0 as we have mentioned here. So this return value 0 is passed back here. So this will be 0, and this 4 plus 0 is written here for this value, and this 3 plus 4, which is equal to 7, is returned back to here, and we have 7 plus 2, which is equal to 9, was back to here, and this value 9 is added with 1 with 10. So this first call a is equal to 1 and 2, 3, 4 will return 10 as a result. This is how recursion works. So the function calls itself, but with different parameters, and it's executed with different parameters. It goes on, and we should have an ending case like this whenever the length is 0, or else it will go on and on. So we have to have this. So we call this as a base case. So it's a general definition of the recursive function. You could also implement complex things with this recursive function, like some mathematical equations are defined recursively, right? For example, factorial is different. N factorial is defined as n into n minus 1 factorial. So this kind of recursive definitions also you could compute with this recursive function. Any doubt?
No, sir. Even sir, I have another doubt which is not concerned with this recursive. Can I ask?
Yeah, sure.
So this, whatever we are, reviewing in these calls, this will be useful for the qualifying exam, is it?
Yeah.
Okay.
You want to have any other topics for that? I could also discuss that.
Okay, but basically this whatever you are covering, it is as per the qualifying exam, correct?
Yeah.
Okay. Okay, thank you.
Yeah. So anyone, we have any other topics to discuss? I think train except are not covered in this qualifying exam. So it's just until week 6.
I think dictionary, you can discuss it.
Okay. So I could discuss this. Yeah. So dictionaries are like, so the general structure of the dictionary will be like, the name will just declare a dictionary. So dictionaries are declared with this curly braces. We have something like this. So this is a general syntax for declaring a dictionary. So what we have is the curly braces, and within that, so this are called as the values that is to the left of this column are called as keys, and the values that are to the right of this column are called as values. So what's this? What is the use of declaring a dictionary like this? Is that we could index a value of this dictionary like this A using this key. As we did in list, we could have a number to index the value for at the specific position. In dictionaries, we could index it using this key that we have defined here. Right? A of 1 will be just A, B will be C. So it's just like naming something. You could also have different data structures here, data types, numbers also. So the value of 2 will be 3. So this is the value. This is what we call as key. So we access the element, the value using key, the key of that particular value. So dictionaries are like more like defining a name to some certain values and accessing that values using that names. So these keys you can consider as the name of that value, and this value is the value of the value. So it's the, you could also have keys of different data types like B and two. And the one thing you can't have as a key for this dictionaries are the mutable data types. So you cannot have a list as the key. If it produces an error, you cannot have a list as a key, but you could have a tuple as a key. So it's a mutable data type. So I think that is not correct. You could have a tuple as a key. This, yeah, like this you could have, and you could also have a tuple as a value, a list as a value. So for values, you would have anything, any object, any kind of object that out there. So with that,
Sir, one question.
Yeah.
What is the real application usage of having a list as a value, name of the value? Is there
so
any?
like this tuple, right? You are asking about like this. What's the practical application for something like this?
Yeah, yeah.
So just say that you have certain points that are defined in the graph, and so you describe like, yeah, so some points in the 2D graph, so that you could have as a 1, 2, right? So that point has some name P, right?
Yeah.
And you could have the name of the names, the point names as a dictionary. So this dictionary has the name of the points defined in it. So like 0, 0, we call it origin, right?
Okay. I get it. I get
Something
it.
like that.
Yeah. Okay. Thank you. Yeah, that's really helpful.
Okay. And yeah, you could have something like this. And on the go, you could also change the contents of this dictionary by adding something to a dictionary like A of. So we have this keys 1, 2, 1, 2, and 3 like that. So we have name, something like that. This value is equal to just like them. And that name. So that's not defined initially, but we added it on the board. And the contents of the dictionary will also be changed. Yeah, you will see the contents of the dictionary. We have another key called name and this value called Python. You could modify the contents of the dictionary like that. If the name key doesn't exist, the key doesn't exist, it will create a new thing. And if the key already exists, it will just modify it. So like one, we have to change it into. You can see the value of the key one is changed. Right. Yeah, this is the basic thing that we do in the dictionary. And we also have some kind of other functions that depend for specifically for dictionaries. Some of it is like, so iterating to the dictionaries. So there are some functions that's helpful when iterate to a dictionary. So let's check what. So normally when we iterate to a list, the values are iterated. So just check what we do iterations like these dictionaries. So for I do something like that for B A, just print B. So this just prints the keys. So when you iterate, we just have the keys there. So you see that 1, 2, 3, there are and name we have added this here are printed. And similarly, as when you try to access the key that's not present in the dictionary, the like A of something, something is not there, you will get an key error as you get an index error on the list.q. You will get a key error. So this is a wrong key that we are asking for the value. So it produces a key error for dictionaries. It's similar to an index error for lists and queues. So this is what we have. Right? So you want to have the values of that, have to print like this. The A of B. So A is the name of the dictionary and B is the key. And when you call that, you will have the values there. You see, one, the key is printed and the value B is printed. And this key is printed, the value printed, like this. So there are certain functions that allows us to iterate to the keys or the values. So they are just keys and values. K dot keys. So this function, similar to that, you normally iterate to the dictionary. You can have see that it has the keys. The other thing is called values. And this iterates through the values like B, this one, and this value, and this value. So you could check that this values and keys, what this values return. So just edit values. So this is of a different type, not it doesn't return a list, it just returns edit values. And similarly, so it could be iterated. So when you iterate this, it will be this values will be iterated. And similarly for keys, the dig keys object is then you could iterate to these values. And there's another function which will be very useful, like items. So this iterates both key and value pairs. So it iterates the value contents of the dictionary as key and value pairs. So you could use this function like if you bring that, it is just prints this as a tuples. The key and values are combined with the see that the tuples. So one thing we learned from tuples are that they could be unpacked. So we could use two variables K and E for E and values. So this tuple, the first element will be unpacked as a key. So thus that's the key there, and this value will be unpacked and assigned to B. That in action. See that K has 1 and the key has. So this items function is helpful in iterating the key value pairs both. Yeah. Any doubts?
No, sir.
we have this same called pop. We have this key like one, that element is pop and it's printed. So this returns the value. So this value. When you pop with the key, it returns the value and the contents of the dictionary is also modified. So that key will not be there. So the key one is removed from the dictionary and the value pop is returned. So that only the key is there. So this pop item where we have another function, it pops the key value pair. Removes the key and value pairs, etc. Just takes the some of the you will have the, so it doesn't pop items, just of some item, some random item from the list. Do not specify that. Just removes one key value pair there. This could be useful in some cases. And there is also a function called get. And this function is similar to, so I think we do like a of 1. So get of 1 will also return the same result. See, for the same. But one thing that's beneficial in using get is if the key is not there, it doesn't produce any error. So like something doesn't produce an error, just returns none. You would also have some default values to return if you don't have that key there. For is equal to here. So if this value is not here, the get will. So, sorry, just keyword or this. Yeah. So it just the default value will be not here, and something is not there, so it returns this default value there. Okay. So the main use of this dictionary data type is that you could store multiple values, and internally it uses a hash function. Like you could think this like the bookshelf or a library's section. You get the section, you give the section name, it just takes out the book from there. So this doesn't take much time. So like going through everything and taking that, just fix that up. Internally, it's efficient to get any value. So you could have a dictionary of 100,000 items, and it just takes a constant amount of time to pick one thing using this name. So that's using this key. So that's much efficient there. We have things like mappings also. So if you want to have some kind of mappings, like the letters and the numbers, you could have a map like that. Okay. For A, I have a value 1. So like coding something, some text into some numbers. B, I have the value 2. Create a different kind of sets of maps, and you could convert this set of A, B, and C, some strings into some numbers. So it's like encoding it into some other values. For that also, dictionaries will be very helpful. Any doubts or anything we have to discuss? Anybody?
Sir, can we change the name of the key here?
So changing the name of the key, so that's not possible here. So if you want to have a new key, so like so you want to have this value 1 with a new key, you could delete a key And so you have to delete this key, so this value, and have this one inserted into a new key. You could do something like that, right? So if this A has the value 1 now you want to have C for this value 1 to do something like A. So it's like C A of C is equal to C is 1. So you one not like A of A. So this value will be assigned to this value, right? So you just print and see what's there. So now for the value 1, that's this, the value that's has the name A is also there, and you could just delete C there. Just this del keyword here to delete A of C. So not A, we have to delete A, right? Yeah. And now the one has the key C. So because the most why that is not implemented in this dictionaries is that you give a name to object, some object, and what's the benefit you have in changing the name of that object, right? So it's like renaming some object, but it will be difficult to access that later, right? What name is changed to do that one also. You just add and do something like this as a workaround. So it's like the dictionary is like a bookshelf, right? And you put some in the first row or the second row, and if you rename something like that, so it's like something has a different set of names, like some section in library, like science and arts. What's the use of changing something like arts to some other thing? So dictionary is used in the cases where you have some definite names and the content. So the books available in the arts section, that may change, but the name of the section arts doesn't change. So you use dictionary in that kind of cases, right?
Okay, so this dictionary can be used later, like it's not for a particular session, it can be reused,
Yeah.
these lists.
So it's not saved in this session. One session, if you run a Python code, that's defined there only. It doesn't saved in any other. You could reuse that dictionary anywhere inside the same program. So okay, is it okay?
No, so it can be reused later, or no, it can be used only within those codes, like the current
Yeah,
session.
yeah, only used in the current session.
Okay.
Yeah.
Okay. Thank you.
Any other doubts?
And sir, what was the difference between this delete and pop? Like pop also, I thought it deleted that key, right?
So pop removes the element from the list and returns it. So when you use pop, b equal to a dot pop of a, like a. So this picks that element and puts into b. So it returns that. So now b will be that element, but del permanently deletes that value from the memory itself. It doesn't return anything. It's just a statement that deletes the key and the value from the memory. But in here, when you pop, the value is stored, returned here, and we could store that something here. If you don't store it there, it's same as using delete.
Okay, thank you.
Any other doubts? But no doubts, I think you can end this
So
in
for
this
the
session.
sample paper,
Yeah.
for the
Yeah, yeah.
sample paper which are given on the site, can we get the answers are there, but can we get the explanation with the answer if possible
So
for the
what
one sample paper?
Which
what
site you're asking?
Sir, this on the website of DAD for the some sample paper are there. So
Sample
their
paper.
answers are there.
Okay, you said that explanation is not given.
Yeah, answer is there.
Okay, okay. So we will check this with the team, and if explanation is there, so we will provide to you.
Thank
But I think you should observe the explanation by yourself to
you.
learn
Okay.
better.
Okay, sir.
Okay? Yeah.
any doubts, or I think could wind up the session.
Sir, I have one question.
Yeah.
In that sample paper, we have only like 15 questions, and there is only one sample paper for Python. So, can we get some more sample papers? Is it possible? Or can you suggest any website uh, in which we can practice the question like the questions it's present in sample paper?
So in last session, I think we have discussed some 15 questions. So that you can also check.
Okay, sir, I will go through the last session. Actually, I was not
Hmm.
present in the last session.
Okay, so
I
just
will
check
watch that
that
video.
that question also.
Okay, sir. Okay, sir.
Anybody?
Yeah, anyone have any doubt, or shall we wind up the session?
So is it possible we can solve one or two problems like last session, like we did in the last session?
Okay, so that problems actually right now we don't have. Uh, so you can watch the session, the previous session. Have you joined the previous session?
Yes, I did. Similarly, if there are two or three problems, I'm just asking for it. I was
Okay, I
present in the
think.
last session.
So that actually problems are configured on the item pool, I think. So we actually currently doesn't have that link in that problems.
Okay, okay, no issues, sir.
Mhm. 1 second. Levin,
Yeah.
do you have this Python mock one?
The
Python
OPP Mark
course?
1.
No, no, not OPP. That quiz mock one.
So the week's content.
Go ever practice test. No, no, no. Go ever that
Yeah.
practice test. Yes.
Yeah. Yeah. This one.
This one. So just last, there's some problems you can discuss.
Yeah. These problems.
Yeah. So yeah, you can quickly discuss the problem.
This in problems here.
So you can just select from the like this, which is based on the list or these data structures. Initial problems are very easy, I think, print statement
Yeah.
like that.
This
These
is
are the
something
things
like,
which we solved last week. I mean, like last session.
So this is the same.
Yeah, same. The same 14 questions. The first one was the same.
Oh,
Yeah,
so
this is the
which
same.
question you are asking to explain here?
No, I'm not asking to explain, but if there are similar questions, we can solve right now. That was my request.
So currently we also have the same set.
Okay.
Or Levin, you can just pick any practice assignment from week 5 like this.
so
Hmm.
this one.
PPS. Yes, this one.
Yes. So this is so okay. Let's go through some of these questions. So this one, this first function accepts a list as an argument and returns a copy of the list. So what all might be the correct answers for this? So consider this function. So we are declaring an empty list here. So for every element in B, we are adding a list of the singleton list that containing that element to this. So in list, this plus operator is used for concatenation. So like we could do that here. So this I think I have missed this concept here. So we say is equal to B. We could have print this A and B, and we could add that, and it will print a concatenated list that's combining both lists. You see, it returns a list that concatenates the both lists. So what if you have a list and so combine the list B and add something to this? So it will be a list. The contents of the B will be here, and also this contents of the remaining contents will also be added. So adding a singleton list also produces the same result. Just added a 3 here. So for this, adding this element is adding this element. So for every element in Q, you just add that with Q and you place that result in Q. So this is similar as adding each and every element from P to Q. So this copies this into Q, but it doesn't return Q. So which means this function basically doesn't return anything. So it returns none, as we discussed there. So this cannot be a correct option. You have to return a copy. So this function doesn't return anything. So this would not be a correct answer. And you could see a similar thing, but with the return here. It's same as this option, but with the return set. So this will be a correct answer. And now we have this append function. We used to add that element here. So we are creating an empty list Q and appending every element from P to the Q. That's adding every element to Q. But you could see that this append function also returns nothing. So when you do this append function returns nothing, but it appends the element to Q. But when you assign this return, that is the none returned by this function to Q, Q becomes none with this line. So this is not also the correct solution. So we could check on that like this. So we have B here, and if you print B dot append of 3, it will return none, and none is printed. But if you append this 3 and then print B, it will be error because this line returns none. And if you assign this none to any value, it will be also none, right? So in this case, the Q the q dot append of this element returns none, and its none is assigned to this. So in the next iteration, you cannot append to a none. So this program will certainly produce an error. So this is not also a correct option. And now here we have, yeah, this appends the element, right? But it does nothing. So this append modify this q by adding this each element from this p here to this q. And this works fine, and it also returns this q, right? And this is also the correct answer. And here, if this function, you are adding an element that is it may be a list or may not be a list, but we are considering this for a general thing. So this element, so there could be a list as an element. So for considering like a list of list will have, so if P is a list of list, that is a list having all lists as input, this could work. But in general, its element could be of any type, right? So you could not concatenate an element of any type with this type Q. So it will also produce an error in general case. But if P is a list of list, this could work. So for our current case, this is not a correct solution. So these two will be our correct solutions. Okay, so this one and this one. Any doubts in this?
No, sir.
Okay. Here we have a function defined over here. So this is a function that does this. So we have to, what are the correct functions here? So x square plus y square, that's x square, and this is y square, and the root is over both x and y, so we have to use parenthesis. So this 0.5, power 0.5 is same as the root, that's power 1 by 2, which is 0.5. So this is the correct answer, and we have to return the distance of the point. So the one having the print statement doesn't return the value. So this is a correct option. This will not be a correct option. And in this, this doesn't accept this coordinates x and y, and it will certainly produce an error because x and y are not defined. So this will be a wrong option. And this, we are saving this value, the same value that we have here, into assigning it to a value d and returning d, which is also same as the first one, and it is also be a correct answer. Just have one extra step by assigning it to d and returning d. This both have the same value return. We have function create matrix. This, so we have to create a matrix except positive integer and value to size in with all 0 elements. We have to return. So definitely doesn't have a return statement, wrong answer. And this we are using nested loops. So we have this A, we have a row defined here, and for each row we are appending 3, I think, n values in zeros here. So each row containing zeros, and we have n such rows. So we only have these rows, but we are not adding these rows to this A. So this A is not changed in this code. So it just return this empty list. This is also a correct answer. Here we are creating n such rows and adding that n such rows to this A. So A will have n rows, and n rows will have n zeros. So this each row has n zeros appended to it, and each n such rows are appended to A, and the A is returned, and so this will be a correct answer. And what's the different? So no, this is not a correct answer, as we are not accepting the value n here, and here it's we are accepting the value n, which is the correct answer. So this is don't have a return statement, not accepting arguments, and this is doesn't add modifying this A, which is wrong. So these three options are wrong, and here we are accepting N and returning A, and also creating N rows with N zeros and adding it to A. So this will be the correct answer. All the answers are they are to accept N as argument, which is not here. No written statement and not modifying E. So this is the correct answer. Any doubts?
No, sir.
This is with these functions. We have yeah, this is distance. So we are using this function metric, this argument metric to decide whether we have to calculate Euclidean distance or Manhattan distance. So Euclidean distance is defined with this formula, and the Manhattan distance is defined as the sum of the absolute values. So we are using this absolute value function. So just check this. What we have to accept x, y, okay. See, this metric is Euclidean. We have to do this right, and if Manhattan, we have to do this right. So we are returning, we are accepting, and if unspecified, it should default to Manhattan. So this is, but we don't have a default argument here, right? So according to the questions, we will have should default to Manhattan. But if not unspecified, metric is not specified, this doesn't default to Manhattan. And this you can see just you can't pass a string as here. You have a variable name here. So this is also not a correct implementation. So this is how we define the default arguments. So the metric is correct. So the metric's default will be Manhattan. The Euclidean distance, A correct, is written, and it's also returned, and it's correct. So here the default is Euclidean, which is not correct. We have to use Manhattan as a default. So that option is correct till now. And metric, you cannot have the default arguments before this positional arguments that we also see. So this is not a correct. The default arguments should be placed after this non-default arguments. That's the positional arguments. This only will be the correct solution. So this third one only will be the correct solution for this question. And here are these functions. This first is calling second, and second is calling third. Third is this. When we call first the second is called here, and the second is when the second is called, the third is called here, and the finishes, then it prints second, and then it prints first. That's how it goes, right? First, when the function first is called, this line is executed first. So here we are calling the function second. So we go here, from here we come here, and from this line is executed, we come from here to here, and this line is printed first. After this line is printed, we come to second, where we come from here to here and continue that function, and we print second. And after the second is finished, so we came to second from this first, the second is finished, and this first will be printed at last. So the order of the print will be third, second, and first. So third, second, first. This will be the correct answer. Okay. Things fine till now. Anyone doubts in this?
No, sir.
Yeah. And here we have that function that we did here. What will be the output? We are calling this add. Okay. Okay. So this. So what if we have this function definition later in school? Function is not defined below. So produce a name error there. So you see, I think you would have a function defined in anywhere And it's in Python also. If you run this as the same script in the whole thing, you don't have this error. It is just print 3. But you, if you run this in console, you just run this line once, and it doesn't have one by one. If you run this, it will produce an error. You just check this out, how this works out. Yeah. And define and copy. So it's not defined. So when this line from Python runs this program, what happens is this function is not defined over here. So we cannot call this fields. After the function is defined, we could call this because A is here. So that's so this answer will be this. We cannot, so this name add is not defined over here. But in C, if you have a function defined anywhere, it will work. But in Python, it doesn't work like that. You have to define the function before you call that function. So this is that. And here we have some math function and this one math function. What do you think will happen here? So this second definition just overrides this previous definition. So in that case, just have this XQ and it will be this one. Just replaces that. So it just finds add NP and change its return a minus. It will have this minus. So this add replaces this add. So the last defined definition will be used if you define more than one function. So XQ is executed and we have this. And this is some function, this conditions and age and prints quality. So welcome of 10 is less than 18. So print was that's then got. God just prints this. And the 15, it's greater than 18. So just click down, ladies and gentlemen. So you are printing this. So the thing is, right? So here you are not printing this. So this function is just called. Here you are printing this. So this function prints this, ladies and gentlemen. And this print statement here also prints none, which is returned by this function. So we are running this function. While this function runs, it executes this. So prints this ladies and gentlemen line. And then this function returns none, and which is printed here. So we'll also have a none to this. So this will be the correct answer. This is a big factor function. So it just checks from, so considering number n, it checks for all numbers that's less than n to 1, whether that number is divisible by that. So it returns the biggest factor of that number. That's the number which the number is divisible by. So this here, this n number, we have number n is divisible by f. So they are finding biggest such f like this. So if m is a prime number, what will be this function return state? What will it return? So here we have it goes until 1, but doesn't have with the value 1. So what is having is, if the number is prime, it doesn't have any other factors than 1 prime. So this loop just exhausts So it goes from n minus 1 and check every number. This nothing will be, this return statement doesn't work because no other number or prime will be a factor of that number, and it just return. So the return statement inside the loop, no, it's not executed. Outside the loop, it's executed. Both return statements are executed. In any case, a function will return and when it encounters the first return statement. So in any function, it doesn't involves in both return statements. Neither of the statement is executed. No, because after it comes out the loop, the statement is executed. So this is also not the right answer. So this is the right answer. Yeah. 11, there is tell by event. Yeah, so they are saying that. So we are defining another function, PQ big function, big factor. So this is, they are saying that this will also return the same values. Select all the correct implementations of the equivalent to big factor, because we have to select the other equivalent implementation. So that will have the same input and output as this one. So whenever a number is brought to this function, we get an output as output. If we get the same output exactly at the big factor, this function will be equivalent to that big factor. So we are trying to find equivalence between these functions. So we could see whether anything is equivalent or not. So here we have this break statement, which means in any case, if it breaks or if it doesn't, it always returns 1. But that's not the case with our original function. So this is not equivalent to our original function. And here, it's also similar thing. So equal. Here we are turning here, right? So let's check whether it goes in. So whenever this prime factor is, so here we are considering the range including 2, right? So n will be of the range 2. So these two return statements is if you break out of the loop, you have this here. Otherwise, you have this 1. So what will happen if you come out of this 2 to the value of m? That we have to check, right? If it's less this, it goes from here is equal to n minus 1 and reducing the number 1 by 1 until the value becomes equal to f becomes 1. Because if f is greater than 1, this while loop runs. And in the last iteration, the no values of f are returned, you will have f minus minus. That is, when f is equal to, it's changed to 1. And then it checks here, and it doesn't matches, and the value of the f will be when it comes out of this loop after exhaustion. So returning 1 after this loop, same as returning f. So in this case, both things will be work as same. So this function and this function works. So like, let me check. So it's not this. Yeah, this function we are returning f here, right? So if you break out of that, f will be also here. So f, we are returning f there and breaking out of here and returning the f here is also same thing. Both are the same thing. So this function break here and return f here, it also returns the same here. Return here, it also returns the same. So this function is equal to that function. And similarly, this is also same. Because whenever you reach out of the loop, the returns will have the value 1, which is same as this function. So last two implementation are equivalent to the original function. Get it? Any doubts? Oh. Let's go here. The concatenate to list and returns P plus Q. So we have to check out the implementations. So we are creating a new list R here and putting every element from P there, and putting every element from Q there. So that's similar to joining this P and Q. The elements of P are added first, and then the Q are added first. Which is same as this, and we are returning R. Okay, so everything works right here. So we are putting the elements of the Q first, but that's not equivalent to P plus Q, but it is equivalent to Q plus P. For this case, this is not the correct answer. And now here we have a function copy, and we have a list here. And here. So this function copy just basically happens this P and here. So just creating a copy of Q. So it's a new list which have that contains the copy of Q, and we are putting P later after the elements of it. So this is similar to the previous implementation, which we have Q elements of the Q first and adding the P. Yes. Yeah. So this is same as Q plus P because the elements of the Q is added here first. So this is not the correct implementation. Here, yeah, this is we have this function copy, which creates a copy of P by putting the elements of P here. So this R will have elements of P, and then we are putting elements of Q, which is same as P plus, and we are putting R. So the first one and the last one are the correct implementations. And we go with the other week's contents or we went up.
I think no. That's it, bro.
Yeah.
Hmm.
And we just finish it with this question. I think this is the final question here. Yeah, we'll just finish it with this. Okay. So this function concatenate. Question 12. Yeah. Okay. Yeah, this is that. Elimination of the function multiply of the list and so P in the Q. You could also have this kind of implementation. So like adding to list produces a concatenated list. Multiplying a list with a number creates a list with at times copy of the list. Like L1 equal to P and L1 times 3 will print element list with this content that is repeated 3 times. So we create a new list repeated 3 times. Therefore, we will have a list with the elements of the list 1 repeated 4 times. So that's what we are. So this is how that function works. They are given. We use 0, it will give an empty list, and we need an empty list with some number. So this is how that this function works. So multiplying the list with the number. Yeah, so we have to implement the same functionality using a function called multiply. Okay, so just check out this. We have to here, and for A, we are concatenating Q with Q. So if you concatenate Q with Q, it produces 2Q, right? So in that case, Q is an empty here. And if you concatenate Q with Q, what will happen? Empty with empty. So it will be empty. After this, it will be empty. This is not a correct answer. And let's check here. We have Q concatenating P with P. So Q will always be P plus P. Not it will be. In every iteration, the same thing is calculated and it will be P plus P. And this is not also the right answer. And here we have Q and concatenating P the queue is concatenated at the end of this P. So P is our original list, and every time, like the first iteration, the queue is added to the end, and that will be our new queue, which has the 2 times of the P, and it's added to the next. This goes on for n times, and we have this. So this will be a correct answer. And in this case, we are concatenating this. We are not defining queue here, so it will not work. So this is the wrong answer. We are having queue here defined. So in this case, like this one, we are just changing the order of queue. So because the value in the P is the same as the value in the Q, but then Q has n times that value. We append that value before or after, it doesn't matter, and these two produce the same result as the final. So these two are the correct answers. So I think we have these things. Any doubts, or we can wind up this session? Yeah, the wind up this session.
Yeah, Vasmi, any doubt?
No, sir. Thank you so much.
Yeah, okay. So actually, for the qualifier exam, just refresh your Python concept. So like this for loop, while loop, and these data structures. So that will be more helpful compared to this solve some problems. Okay, so you maybe need to apply the dry run on the some codes and identify the output like this type of questions you will get. So just refresh your concept in deeply of the Python like. Okay. Yeah.
Thank you,
Okay.
sir.
Yeah. Thanks everyone.
Thank you.
Thank you, sir.
Yeah, with this, you are asking something?
No, thank you, sir.
Okay. Yeah, thanks. Bye.